dear students of class 9 and class 10. Uh, Welcome to you all in online lecture. This is lecture number 2 on the topic equation. It is discussed in the chapter 5 in your textbook. In lecture 2, I am going to discuss about equations involving radicals. I am Shudipan Bhattacharya here. Now let's start. So for preface, that is introduction, we are going to discuss about radicals. What is radical? The expression which are involved with square roots, cubic roots or nth roots are called radicals. Root over a square plus b square, this is the radical, and an expression involving radical is minus b plus root over b square minus 4ac divided by 2a. The equations which contain radicals are solved by squaring or cubing or taking same power at both of the sides of the equation. For example, to solve the equation cube root of x equal to 2, we have to cube both sides, and there are some special techniques to solve this kind of equations, because in common techniques it may become very difficult to solve. So what is the problem? Squaring both sides of an equation involving radicals may lead us to a wrong solution. For example, root over 1 minus x equal to minus 3 is an equation. Squaring both sides, we get 1 minus x equal to 9. X is equal to minus 8. Now, if we try to satisfy the equation, that is, if we put minus 8 instead of x in the given example, that you can see at left side we will have root over 1 minus x, that is 1 minus minus 8 equal to 1 plus 8 equal to root over 9, that is 3. Now at the left side we will get 3 and at the right side we will get minus 3. Therefore left side is not equal to right side. Practically this equation root over 1 minus x equal to minus 3 has no solution. So but this example shows us that squaring both sides of an equation involving radicals may lead us to a wrong solution. This kind of unwanted solution or roots of an equation is called extraneous root. To avoid extraneous root, we can avoid squaring both sides, which is not always possible, or test or verify the roots after solving the equation. As the first option is mostly impossible, so we will go through the second option. Some examples. Example 1. So we will solve this equation. The solution. Now we will take one of the radicals at right side and we will take square of both of the sides. In x minus 2, this comes from squaring root over x minus 2 from the left side, and at the right side there are two terms. Therefore we will square these terms using whole square formula, that is 1 square plus 2 into a into b, that is 2 into 1 into root over x minus 9 plus root over x minus 9 whole square. X minus 2, 1 plus 2 root x minus 9 plus x minus 9. Now look at this. By cancellation and changing the side, we get minus 2 minus 1 plus 9 equal to 2 root over x minus 9, which gives us 6 equal to 2 root over x minus 9. Now we will divide both of the sides by 2 and we will get 3 equal to root over x minus 9. We will square both sides again, that is 9 equal to x minus 9. We will get x minus 9 equal to 9 and x equal to 18. Now we have to verify the result because we have squared 2 times. To solve the equation we have to verify the result, and left side equal to root over 18 minus 2 minus 18 minus 9. We have put 18 instead of x, and which gives us 1, and right side is also 1. Therefore the solution satisfies the equation, and the solution is x equal to 18. I think you have understood the technique of the solution. Now we are going to solve another example where we have 3 radicals, one at the left side and 2 at the right side. So our second problem is 11x minus 6 equal to root over 4x plus 5 plus root over x minus 1. We have squared both of the sides. At the left side squaring, and the root will be vanished, and at the right side we will have the whole square. We will use the formula a plus b whole square, and then we will get 11x minus 6 equal to root over 4x plus 5 whole square plus 2 into root over 4x plus 5 into root over x minus 1 plus root over x minus 1 whole square, treating this term 4x minus 5 as a and x minus 1 as b. Now look at this situation. 11x minus 6 equal to squaring the root over, we will get 4x plus 5, and 2 root 4x plus 5 into x minus 1. Using the property of index we have this term, and squaring root over x minus 1 we will have x minus 1. Now you can see that we have taken all the terms excluding the radical at the left side. This 5x come from 4x and this x. They are 5x, and if we take 4x and this x, 5x at the left side, then it becomes minus 5x, and this minus 6, and 5 and minus 1, that is 4. If we take 4 at the left side, and it will be minus 4, and 2 root over 4x plus 5 x minus 1, and this is the same as it was. In this line we have normally simplified the expression of the left side. In this line we have divided both sides by 2. Now we will square both of the sides. It will give 3x minus 5 whole square at the left side. And then using the formula of a minus b whole square, we will get 9x square minus 30x plus 25, and multiplying the expressions at the right side we will get 4x square minus 4x plus 5x minus 5. This gives us 5x square minus 31x plus 30 equal to 0. Now in this line we have taken all the terms at the left side. We have 9x square at the left side and 4x square at the right side. Therefore, taking 4x square at the left side, we will subtract 4x square and it becomes 5x square. Here we have minus 30x, and this 4x will come at the left side as plus 4x, and this 5x will come at the left side as minus 5x, and in total we will get 31x, and this 30 is the result of 25, and taking the minus 5 at the left side we will get plus 5, that is 25 plus 5. Now using middle term 5x minus 6, as we got 5x square minus 31x plus 30 is equal to 0. This is a quadratic equation. You can solve it by using the general formula of quadratic equation, or you can use the technique of middle term, and I have used middle term here. Therefore 5x square minus 25x minus 6x plus 30 is equal to 0. And here after using middle term, you will get x minus 5 into 5x minus 6 equal to 0, which implies that x minus 5 equal to 0 or 5x minus 6 equal to 0, which gives x minus 5 equal to x equal to 5 or x equal to 6 by 5. So now it's the time of verification. We have used square, so you have to verify. Left hand side will give us 11 into 5 minus 6 root over 7 49 7, and right hand side equal to 7. Therefore x equal to 5 satisfies the equation, and it's a root of the equation. If x equal to 6 by 5, then left side equal to 11 into 6 by 5 divided by 5 minus 6 root over 36 by 5, that is 6 by root 5, and right hand side equal to 4 into 6 by 5 plus 5 root over, and root over 6 by 5 minus 1 equal to 7 by root 5 plus 1 by root 5 equal to x by root 8 by root 5. Therefore x equal to 6 by 5 is not satisfying this equation, so we have only one solution here, which is x equal to 5. Third example here, problem 3. You are watching the third example. In this equation we will learn how to simplify an equation or expression by considering a new variable. Solution of this equation comes like this. This given equation, root over x by x plus 16 plus root over x plus 16 by x equal to 25 by 12. 1 for this equation. Look at the first radical, root over x by x plus 16, and look at the second radical. It is the inverse radical of the first one, root over x plus 16 by x. So the same expression comes with its inverse at the second term. So root over x by x plus 16 equal to p. P is the new variable here, equal to root over x by x plus 16. Now at the second expression we will get then root over x plus 16 by x, which is equal to 1 by p. Now we get the equation becomes p plus 1 by p equal to 25 over 12. Now multiplying both sides with p, we get p square plus 1 equal to 25 p by 12, which gives us 12 p square plus 12 equal to 25 p. Here we have multiplied both sides with 12. Now taking all the terms at the left side, we will get 12 p square minus 25 p plus 12. Now we can see that this equation 12 p square minus 25 p plus 12 is a quadratic equation of one variable, so we can use middle term or we can use the general formula, whatever you like you can use here. So I will prefer using middle term, 12p square 16p minus 9p plus 12 equal to 0. So by this way you can take 4p as common and minus 3 as common, and then we'll get 4p minus 3 into 3p minus 4 equal to 0, and then 3p is equal to 0 or 4p, and then I will get 3p minus 4 equal to 0 or 4p minus 3 equal to 0, and thus 3p equal to 4 or 4p equal to 3, and so we get 4 by 3 or 3 by 4. And look here, these are the values of p, that is p equal to 4 by 3 and p is equal to 3 by 4. So we are supposed to calculate the value of x, but we have found the value of p. Therefore we will have to consider these two cases as the value of p and find out the value of x. Taking equation 2 in consider, we will get root over x by x plus 16 equal to 4 by 3. Now to remove the root, we will square both sides and then cross multiplication. 9x plus 16, 9x equal to 16x plus 256, and then minus 7x equal to 256, and then x equal to 256 by 7. P equal to 3 by 4. Now root over x by x plus 16 equal to 3 by 4. Now I'll get 9 by 16 here, and then I will cross multiply the equation. 7x equal to 144, x equal to 144 by 7. And we have two solutions. One is 256 by minus 7, another one is 144 by 7. And for verification we will use a scientific calculator, and you can use this. I have used it and written the result only. X equal to minus 256 by 7 we get, which satisfies the first value of x, satisfies the equation, and second solution also satisfies the equation. Therefore these two solutions are actually the solution of the given equation. So you can see here the problem is root over x square minus 6x plus 9 minus root over x square minus 6x plus 6 equal to 1. You can solve this equation in manual method, like by taking this radical at the right side and then square both of the sides. But it will be simpler if we take x square minus 6x as a new variable. So let's see what happens then. X square minus 6x equal to p. Then we will get, and the given equation stands like p plus 9 minus p plus 6 equal to 1. Look at this equation. This equation is very similar to the first equation we have solved. And then we get, now simplifying this equation, we will get root over p plus 6 equal to 1, and we have root over here, so we will square both sides again, and we will get p plus 6 equal to 1, and we will get p equal to minus 5 or p plus 5 equal to 0. Now we will replace p by x square minus 6x. Now as this is a quadratic equation, x square minus 6x plus 5 equal to 0, we can solve this equation by middle term or by use the general formula, and whichever you use you will get the value of x equal to 5 or x equal to 1. Now to verify the result, you can use x equal to 5 or x equal to 1, and left hand side will be 1, and if we take 1, then also left hand side equal to right hand side. Therefore both of the value of x are taken as solution. Therefore x equal to 5 or 1. So these were the four equations we have taken as example, and you will see some more example in your textbook examples. Now, seeing all these examples, you have to try to solve more uh, problems which are given as exercise in your textbook. Like in exercise 5.2, you will have a bunch of problems, some of which I have solved here, some of which are not solved yet. So I suggest you to solve all the problems from your textbook. Also solve the examples given in the textbook in different methods if it is possible. I think you are waiting to solve these equations by yourself very eagerly. For this kind of equation, you must remember that sometimes changing the side of a radical may make this math easy, as we have changed the side of one radical at our first example, and you have to use the formula of a plus b whole square or a plus b whole cube etc. correctly to solve this equation. You must verify your solution. Sometimes it makes the math easy to converting the equation smaller by assuming a repeated bigger term as a new variable. Thank you. This was enough for today, I think, and stay home, stay safe, continue study with best wishes. Goodbye.